This is Mrs. O'Neill for Chapter 6, the Periodic Table. Repeat after me those vocab words. Number 1, alkali metal, alkaline earth metal, anion, atomic radius, cation, electronegativity, halogen, inner transition metal, ion, ionization energy, metalloid, metal, noble gas, nonmetal, periodic law, representative element, and transition metal. As always, watch the rest of this video, copy down those notes, and then in class you'll have time to define those terms by either looking through the chapter or the glossary in the back. And again, we're going to have that vocabulary quiz most likely after section 2, and it will be matching. So section 1 is about organizing the elements. So your objective is going to explain how elements are arranged in that periodic table, compare the early and modern periodic tables, and classify identify the three broad classes of elements. In 1916, a self-service grocery store opened in Memphis, Tennessee. Shoppers could select items from shelves instead of waiting for a clerk to gather the items for them. In a self-service store, the customers must know how to find the products. From your experience, you know that products are grouped according to similar characteristics. You wouldn't expect to find fresh fruit with the canned fruit or bottled juice with frozen juice. With a logical classification system, finding and comparing products is easy. In this section, you will learn how elements are arranged in the periodic table and what that arrangement reveals about the elements. So think about a grocery store today. Most grocery stores, as soon as you walk in, is the fresh fruit aisle or the vegetable aisle. And have you ever noticed that most of your grocery stores have the milk and the bread all the way in the end, where you have to actually walk through the entire store? There's a reason for that. Most people go to the grocery store more often than their just normal everyday or weekly trip, I should say, and have to pick up milk or bread throughout the week. Well, they do that because you might be, inclined to look around while you're walking through the entire store and pick up an item or two that you weren't supposed to. Anyways, you should have watched the intro video on the atoms and the periodic table. Here are my notes. Again, I'm going to go through these kind of quickly because you should write down your own. So he talked about that periodic table and what those numbers represent. He also talked about how that Bohr model, he came back to that Bohr model and he talked about that period number represents the energy level and how many electrons are in that particular energy level according to that SP, D, and F, stuff you already know. And remember down here then is where those numbers of electrons come in handy. So how is the periodic table organized? Well, he also talked about certain trends, and the one trend he talked about was valence electrons. And he talked about how group 1 has 1 valence electron, group 15 has 5 valence electrons. Remember, we're not going to worry too much about this D group or this transition metals in here, and we'll talk about that later as well. So here's a little extra on valence electrons just to get hopefully a better understanding. So if you haven't wrote too much notes, you might want to add some of these down. So if we look at electrons in calcium, we have these electrons which are on the inside electrons. We're going to call them core electrons. And you're going to understand a little bit more about these as shielding electrons. And what are they shielding from? Well, these inside core electrons are shielding the nucleus from the outside valence electrons. And those valence electrons are going to be really important when we talk about bonding. So again, here's our calcium atom. And when it changes into an ion, it's going to have a +2 charge. So what does that really mean? That means it's going to lose these outside valence electrons. And what happens is that whole energy level goes away. So this is something we're going to see in the future where the atom now changes into an ion, and a positive ion or a cation is going to be smaller than the atom it originally comes from. Why? Because not only are you losing those valence electrons, you're losing then that whole outer energy level. So again, this ion is going to be smaller than the original atom it comes from. So now let's look at nitrogen though, however. Here's a nitrogen atom, and what's going to happen is, ooh, I spelled that wrong, but I'm not fixing it. I'm already 5 minutes into this video. So we're going to gain outside electrons. So here we have a pair, nothing's going to happen there, but we can add an electron here, an electron here, an electron here to get 3 more pairs of electrons. And what happens is that ion has now gained those electrons. And I don't know about you, but when I gain something, I become larger. So the actual nitrogen ion is going to be larger than the atom it comes from. And again, we'll talk about more in detail about that, but just to get you a preview of what's to come. He also talked about the group names, right? He talked about the alkali metals and the alkaline earth metals and so on. So again, because of the periodic table is arranged the way it is, we can give these groups certain names because they're going to have similar properties, just like that grocery store. So off to your packet of notes. So how did the chemist begin to even organize those elements? Well, just like we talked about, they're going to start grouping those properties, similar properties, into groups, right? So if they have, let's say, 10 elements that they know of, well, if 2 elements do this and then 3 elements do that, now they can have a group of 2 and a group of 3, and again, we're going to start grouping these similar property elements into their own groups. So make sure to pause the video, fill in the blanks, and then play to hear my words. So in the 1700s, which you're not going to have to know the time frame, you are going to need to know certain men and what they did. But this is, again, just a little history to give you some background. So in the 1700s, about 13 elements were identified, and here's the list of them. Notice, iron, really, really old. Silver and gold, really old. Lead and zinc, right? These are metals that they have found in nature, except for iron, of course. That one is only found in a compound. A couple years later, 5 new elements were found. Now, what do you notice about hydrogen, nitrogen, and oxygen? Oh, now gases were discovered. So in the very beginning, of course, they found things that they could find in Earth. Most of those were solids. Now they're doing more and more experiments, and now some gases were identified. So this guy, Döbereiner, he's the first guy that you need to know. You should know that he's from Germany. Döbereiner with those 2 dots on top of the O should give you that clue. But you also need to know that he discovered what we call triads. So we have all of these elements are known, and now he's going to start grouping them together because now they have similar properties. So if you look at chlorine, bromine, and iodine, can you pause the video, pull out your periodic table, and can you find them on the periodic table? Okay, so hopefully you paused the video, you found them on the periodic table. They should be in group 17. They're in the same group. So he put them together as a triad meaning 3. So when they were discovered, he said they're very, very similar characteristics. So they're going to have, they're going to be in its own group. And guess what? In today's world and today's periodic table, they're still there. So think about how many years ago he put them together, and they're still there. Now, they don't look very similar though, right? We have chlorine gas, we have bromine as a liquid, and we have this iodine solid. So even though they're in the same group, they might not look the same, but they react the same with other elements, okay? So chlorine, bromine, and iodine all have 7 valence electrons because they're in group 17, so they're going to react with other elements in a very similar way. In 1869, we have this guy by the name of Mendeleev. He was a Russian chemist, and he actually was the first guy to publish a periodic table, and that's why he's really well known for the periodic table. If anybody ever says, hey, who's the guy that you know about the periodic table? They're going to say Mendeleev. He's the one that's known. However, he did his periodic table according to increasing mass. We want to pay attention to that. There's a reason. So this was Mendeleev's first periodic table that he published. Here's another picture of it. This is more in his language, but it says in his early version of the Mendeleev's, the rows contain elements that were similar properties. So his rows are more like our groups today. So it says a fourth element is grouped with chlorine, bromine, and iodine. So here's chlorine, bromine, and iodine. Who's that other element that's in there? Fluorine. Oops, you got it, fluorine. So why was Mendeleev, though, so amazing? Well, he was amazing, and I'm going to go back for a second. Hopefully you wrote this information and you're reading as you're writing. But if you notice these blank spaces, he left a couple of question marks. The reason he left those question marks is he said one day an element's going to be discovered. I'm going to leave a spot there because that's where it belongs. And so for the most people, we're like, what are you, crazy, right? You're another alchemist that's crazy thinking he can change metal into gold. But the problem is he was actually correct. So his predictions, his spaces in the periodic table, one day an element was discovered and the chemists were like, oh, Mendeleev was right. It goes boom right there. So he was amazing because not only did he leave these spaces and people thought he was crazy, but he actually predicted these elements that were undiscovered yet, and he did that correctly. However, in 1913, many years later, this guy by the name of Henry Mosely, again, you need to know last names, he actually was a British physicist, and he arranged his periodic table slightly different. He arranged it according to atomic number. And as you know, that is today's, or the modern periodic table. So there's two main periodic tables. The one that was by atomic mass by Mendeleev, and one by atomic number, which is the one we use today. Because if you notice, every single element goes in order of increasing atomic number, right? And by ones, which is awesome, right? Everything is by ones. So then the periodic law, one of your vocab words, is when those elements are arranged by increasing atomic number, those properties of the elements tend to repeat. And we're going to talk about, because those elements repeat each other, kind of like chlorine, bromine, and iodine, they're going to be in the same group, and some groups we actually even give them a name, a group name, or sometimes people call it a family name. So there are three classes of elements, the metals, and there are also two inside classes of metals, the transition and the inner, and then you have the nonmetals and metalloids. So here are some properties. So again, pause, fill in the blanks, make sure you're reading as you're writing. I'm not going to really go over this. This is just information you need to know. These are properties of metals. And I like to say that you can use a mallet for metals that are malleable. So that might be a way to remember that metals are malleable. That's a property of theirs. The transition metals are just from those groups 3 through 12. And the inner transition metals are those last two rows on the very bottom. And we're going to talk about those later. They're called the lanthanide and the actinide series. Some properties of nonmetals and properties of metalloids. A lot of times I'll just call them oids. All right, are you ready for a quickie quiz? Pause, read, see if you come up with an answer, then play to get the answer. Hopefully that makes sense. Number 2, hopefully you paused, came up with an answer, and got that one. And number 3, again, pause, make sure maybe you have to go back and read that section of your notes to come up with an answer, and that's okay. That's what learning is all about. And hopefully you came up with that answer. All right, we'll see you in class.